very much, and good afternoon. So we're going to kick off today's afternoon events with McSwain, and she's going to be talking about water quality and groundwater levels in three aquifers that Richard Sproul had introduced earlier. So she's going to look at the superficial aquifer, the Castlehane, and the Pedic aquifers over the period 2012 to 2013, and discuss how groundwater levels and water quality has changed over that period of time. And so without further ado, I'll hand it over to Christine, and she's going to speak for 20 minutes or so. After that, I'm going to introduce the next speaker from the USGS, and then he's going to talk for 20 minutes before we get into questions and answer session with him then. Christine?
Thank you for the invitation to speak to you all this afternoon. Is that better? Yes. Okay. Sorry. We conducted a study in the greater New Hanover County area, we being USGS, during the period of 2012 to 2013. I don't know how familiar you are with USGS. USGS is the U.S. Geological Survey. We are a federal agency. We're under the Department of Interior. We are not a regulatory agency. We are a research-based agency. So unlike EPA, we don't write rules and regulations. We can't enforce anything. We collect data and make interpretations from that data and provide it back to the community at large. You may be familiar with our string gauges. So when you're driving down the highway, you may see boxes on the side of the road at a bridge with an antenna. And we have an extensive network of that across the United States that are used to predict floods during Hurricane Joaquin. There was a lot of coverage of our string gauge network, both in South Carolina, some here in North Carolina as well. But back in 2012, we conducted a study here in New Hanover County, and it involved collecting a lot of data on the groundwater system. And where did this data come from? Well, we began a cooperative agreement with the Cape Fear Public Utility Authority to survey groundwater resources, because it had been more than 40 years since there had been a comprehensive study for the greater New Hanover County area. And that study was conducted by George Bain, and it was published in 1970. But the majority of the data he being George Bain, had collected in 1964 and 1965. And why did Cape Fear Public Utilities feel that it was time to update that study? Well, as you know, and has been discussed, the greater New Hanover County area has exploded with population. There are greater demands on the groundwater system than there have been over time. The area has grown. And so this updated information would provide a much better understanding of how this growth has affected the water quality and quantity of groundwater. So what was our general study area? It was a box, roughly, that surrounded the New Hanover County area, extending up into Pender County, southern Pender County, and over into eastern Brunswick County. Dr. Sproul talked a little bit earlier today about the different hydrogeologic and geologic units that make up the aquifers beneath the New Hanover County area. I'm not going to go into a whole lot of detail. He mentioned that there are many deeper aquifers. This study focused on 3 of the shallow aquifers: the superficial aquifer, which is the unconfined aquifer or the water table aquifer, the Castlehane aquifer, which is that limestone aquifer that may or may not be confined by a clay unit, and then the deeper PD aquifer, which is the one that the ASR well is in, and that's a sandy aquifer that's beneath the Castlehane. So the first part of our study involved updating a digital elevation surface, and this is basically a more modern topographic surface. It gave us a stable elevation surface of which to base all of our data. And this is important because it gave us a reference to go back to and base our water level data from. And we were fortunate in that the year that we started, they were also updating, they were dredging the Cape Fear River. And so we were able to incorporate the dredging data that they were collecting at the Cape Fear by the Corps of Engineers. So when they collect the dredging data there, they put it up on the website, and we were able to tide adjust that and integrate it together. So this gave us a good elevation picture of not only what is the land surface that's above water, but also what does the channel beneath the Cape Fear River look like too. So how did we find wells in order to conduct the study? We learned pretty quickly that it was going to be impossible to recreate the Bain study. The original wells, information about where they were located had been lost. The study itself did not publish latitudes and longitudes. We didn't have street address. We had dots on a map. The map was very tiny. The county was very large. There was no way to recover that data. Drilling new wells was not an option. It's very expensive to drill new wells, as Nat Wilson touched upon earlier. And so we decided to rely upon citizen volunteers. We went on a media campaign. We released a request to the press in April and May of 2012. We ran a release in the Wilmington Star News. We went to Channel 14 on Time Warner Cable. We released it to several smaller e-journals, and this was pretty successful. We were able to inventory about 167 domestic homeowner wells that we went out and saw in June of 2012, and ultimately about 50% of those we were able to use in this study in some way. We were able to inventory other types of wells as well. We talked to local public water supplies, so obviously Cape Fear Public Utilities. We went to Brunswick County, Wrightsville Beach, all of the major public water supplies. We talked to local industries, so Corning, anybody who used groundwater. We also talked to other large water users, such as golf courses. This presented its own set of challenges. As you can see, my colleague Eric here is trying to collect a sample from an outfall that's actually groundwater posing as surface water. So they're pumping that's to a one common outfall that's going into a pond. But that really is groundwater. And then we inventory monitoring wells as well. So again, Nat mentioned that there are 3 monitoring stations that the state has here in New Hanover County. There are others in Brunswick County. Bald Head Island has several. A total of 240 wells were used in order to produce this final report. We created an updated hydrostratigraphic framework. About 146 wells with reported data, driller's logs, or geophysical logs were used to create it. And what this does for geologists is that it creates spatial positions of major boundaries of the formations. And this also creates a skeleton that groundwater modelers can use later in order to create flow models. And in layman's terms, this is an interpretation of how sediments were deposited during the geologic past and how they now interconnect in order to transmit groundwater. So let's just look at one of these cross sections. So Dr. Sproul and several other people had showed one of these that went from I-95 across to the coast. So let's look at one for just New Hanover County. So this one goes from Hampstead, the big C up at the top is up at Hampstead. The C prime down at the bottom is at Bald Head Island. So from left is where Hampstead is, to the right is Bald Head Island. There is a fair amount of vertical exaggeration here. So there's 100 times vertical exaggeration in feet on the vertical scale versus the horizontal scale. So the other thing, let's see, again, like everybody else, I'm going to point this way rather than that way. Sorry. So this is real elevation of the land surface from that digital model that we had updated earlier. So you can see things like Futch Creek is here, Pages Creek is here, Bradley Creek is here. I probably blew the pronunciation of that, I'm sorry. Futch Creek? Okay. Sorry. As long as I spent down here doing this study, you'd think I would get it right. The brown sediments up here at the top are the Castle Hayne Aquifer. This light brown up here is a confining unit, so it's a clay. It's separating that surficial aquifer from the underlying blue of the Castle Hayne. And then another confining unit, which is a clay, which helps retard movement of groundwater up or down. And then this underlying larger blue is a PD aquifer. Of note of this, and the reason that I'm showing it, is because this one area, my pointer is dying, right here, which happens to fall in the Masonboro area, is lacking that confining unit. And so what that means is that the two aquifers are interconnected. And so this allows the free movement of water up and down. So we conducted groundwater level and water quality sampling. We conducted both together in August and September of 2012 over a 2 to 3 week period. And the reason that we chose that time is because that's a very high volume time for groundwater usage. It falls around Labor Day. And so everybody's in their pool, they are using a lot of water. It also is at the end of the summer, usually when people have been irrigating all summer long. Summers tend to be more dry than wet. Unfortunately for us, although it had been a very dry summer, as you can tell from the picture on the right, which is actually from a lady's backyard in Hampstead, that pond is normally full. Instead, it was dry. The two weeks of the year, I'm not quite sure how that happened. It always happens that way. We got dumped on the entire time we were sampling. We also did groundwater level measurements 6 months later in March, which is when it tends to be recharge season, so when things tend to be wetter. I'm not going to talk about the March water level sampling. I'm going to kind of skip that. We'll focus more on August and September. So Dr. Sproul showed this picture a little earlier about groundwater levels and artesian or confined water levels versus unconfined. So I'm not really going to belabor that anymore. But we did measure 35 water level measurements in the Castle Hayne aquifer and 31 in the PD aquifer. And what we saw in the Castle Hayne, for the most part, was fairly typical and what we would expect. So, in the lower end of New Hanover County and Brunswick County, what we would like to see is that water flows from a higher elevation to a lower elevation near the coast, with an elevation of 0 sitting right at the shoreline. However, as you go into the upper part of New Hanover County in the Castle Hayne, this elevation of 0 has kind of shifted off the shoreline and has moved inward. So that's showing that there is some groundwater depletion going on. But it's not too bad for now. But groundwater is still moving from inland towards the sea. We are seeing a gradient that's moving from New Hanover County towards the northeast Cape Fear River, which we would expect. And it's because there's a topographic high there. So it's moving from high to low. In the PD, we see a pumping center up here in northwestern New Hanover County. And so groundwater is moving from northern Brunswick County into this pumping center. Again, moving from central New Hanover County towards the northeast Cape Fear. Moving from the sea back in towards northeast or New Hanover County. This is not ideal. We would prefer that it be going the other way. But things look better in Brunswick County. So in terms of water level difference, well, now this is comparing Maine to our current water level information. What we see, let's go backwards. What we are seeing in the Castle Hayne is that there's actually an increase in water level in central Wilmington, which makes sense because in the 60s there were wells in downtown Wilmington. There are no longer wells in downtown Wilmington. And we see a depletion in the northeastern New Hanover County area, which also makes sense because we now see more population in that area of New Hanover County. In the PD aquifer, we are seeing larger depletions in northeastern New Hanover County and some here in the southeastern part of Wilmington. What about water quality sampling? We looked at 97 well sites, 42 in the Castle Hayne, 43 in the PD aquifer, 4 surface water sites. Dissolved iron. Any of you that have a well that you use for irrigation, you may have noticed this rust color. It's an aesthetic nuisance. It is on the EPA secondary drinking water standard. That's for large water suppliers. That's not for your home well, but we use it as a guide. It is a natural microbial process. What's important out of these maps is the large red dots. Any of the small dots are that 300 microgram per liter number. And so you see this large concentration up here in northeastern New Hanover County, down here in Brunswick County, in the PD, again, up here. And it is really an indicator of where the confining layer is thin, at least in the Castle Hayne, and where you are getting mixing and not microbial degradation. Dissolved chloride, 250 milligrams per liter on the EPA secondary drinking water standard. Because of taste, the highest chloride is measured in the Castle Hayne was 7,350 milligrams per liter. In the PD, it was 919 milligrams per liter. Both of these were in domestic wells that were near Futch Creek Road. So if we look at dissolved chloride, that 250 milligram per liter line is up here in northeast New Hanover County. In the lower part of Brunswick County, it's down here by Baldhead Island. In the PD, a little bit right here. One anomaly over here in Brunswick County. And again, up here by Futch Creek. So what difference did we see between 1965 and 2012? We see approximate 250 milligram per liter difference up here in the northeast of McCastle-Hayne. Small difference over here in the PD. Indicator of saltwater encroachment. So there's a whole lot more that was in the study. I left a whole lot of data out of this talk. If you're interested in any of the digital chemistry data sets, you can download them at this website, or any more detailed information or graphs. And I guess that's it for questions. Chad is going to talk next.